was trying to get our friend David Brown on as well, but
yeah, it would be good to have him on.
Well, he was talking to me and said, "You had Andy on? Get like I want to be on when Andy's on. I want to talk to him," because he was on the show talking about he found so many wonderful pictures there. We met him through the Electric Universe Geology page, and he was like, no, take a look at this and take a look at this, and he trolls Google Earth and looks for images and up close, because a lot of these places have been already photographed. And
right.
They're attached to Google Earth, and he's given us beautiful albums full of points of view we never saw because, well, to be perfectly frank, I never thought to do that. Welcome to the September 9th edition of The Electric View. I'm Neil Thompson. Today we have Heather, Dave, Jim, and Robert, again with our special guest, Andy Hall. We will be expanding on Part 1, discussing landscapes on other planets, a little bit of the myriad of Velikovskian theories, and how the clouds of Jupiter seem to be related to mountain ranges and landforms on Earth. Please don't forget to like and subscribe below.
Hey, there's an article in well, I'm not sure what publication it came out in, but it's another reporting on another NASA study on the moon, and there are these figures they call the swirls on the moon. And this article says, aha, we found it. We've discovered the cause of the swirls. But what they have discovered is that there were magnetic signatures on these swirls. And so now they're theorizing that these magnetic signatures are because these are volcanic flows and that reached over 600 degrees Fahrenheit, and iron evolved out and then magnetized, leaving these remnant magnetism around these things. But as there's the swirls. There's one of them right there. There's a picture on the right hand side, the second row. Yeah, that one you got the pointer on. Go back. That's one of the swirls right there that they're talking about. And it has, they said, a thin blade of magnetized something underneath. And they say it's either a volcanic dike or a volcanic plug that's magnetized that leaves a signature. Anyway, their explanation is like, well, this is like the way they describe it in this article is like, this is the only possibility. We figured it out, and this is it. Nowhere do they mention electricity anywhere in the article. I mean, this magnetism just happened because of heat. That's what they're... It just doesn't add up. I mean,
that is a beautiful image, by the way. I mean, look at that. And what are they talking about? I mean, it looks like folded dust, or something, like almost like it's like you're looking at a jellyfish, maybe, or something.
Yeah. And look at the rill that leads away from it is just the windy rill that tail that leads away.
And it also happens to be...
Looks like there's two of them.
Look at the action in there.
Well, yes, and that must be like hundreds of miles long, and there's a crater in the middle of it, and a couple little dots of craters across another part, as you can see, and then there's even another crater at the far end. One of the rills ends right on a crater just down near, where the scale says in kilometers to the bottom. If you go further to the left from the zero, you can see another crater there. Yeah, right down there in the corner. And it's like it just ends right there, like on the crater.
Yeah, it ends at that crater. Exactly. Yeah. Like a little tadpole there.
Right.
Find those
that's a better word.
And you do. You actually do find those all over the place. They're... one of the things that I mentioned when we were in my presentation there, we were talking about, and of course me and you talked about it, was just the way that we call those certain things, like on the moon, they're called rills, and they're trying to associate them now with glacier movement or something, and because that's what we think they are on the Earth when we see these things, and they're because they're called like eskers or something like that, and you get these builds up, which looks like instead of a carved chain, like you would get like a series of craters chains, like dot 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 dot, you get exactly like that. Like you're looking, you can actually see in that detail the action of see how that has these two trails and how they're irrespective of the beautiful dust of the almost lifelike quality of the dust, fire-like quality of it. There's this material that looks like we'll call them mountain ranges, but I don't know how big this is in relative terms, but you can imagine, well, besides there being two of them, that they were interacting with each other as they were being laid down, and you can they call some of this time, they say, oh, it's raised like that and it's just dirt. Oh, it must be, it was constricted by a glacier, and that's what made it look like it does. And obviously this doesn't really pan out with the moon, so they have to come up with a different process, but that's what they are on Earth. That's what they call them. And
does anybody else find it curious, the shape of the thing next to it, the craters, how they kind of arc in the same, in like a semicircle? Like there's motion around it in the craters as well.
I think you're right. I think it could even be a positive, negative thing.
Yeah.
But at a much lower pressure than obviously Earth. So
It's very cool.
I'll let you drop in there, Andy. I just try to.
No, I just wanted to bring that up. I just happened to be reading that article just before the call, and so I thought I'd bring it up. It was kind of interesting. I happened to find it. I can't remember the publication, but it's listed on Real Clear Science. If you go to the Real Clear website under Science, then that article is featured today.
Sorry,
I saw something on that about someone posted about that on the geology thing.
Mystery swirls of the moon hint of their magnetic secrets. Yeah, Real Clear Science. Okay, yeah.
This one?
Yeah. It's lunar swirls down below. Keep scrolling down a little bit.
I saw it for a split second there.
Yeah, it's trying to show you advertising. It'll bounce.
Right.
Yeah, the lunar swirls point to moon's volcanic activity, I think it said, something like that.
It's the second one and the most latest. Yeah, I saw it there.
Did you? Oh, okay.
It's up at the top, second row of red letters. Latest research.
Oh, here we go. Yeah.
Rutgers.
Yeah. Tibbs.
I'll buy you a beer.
What are you trying to call?
Dibs. No, but you're, if they were real clear, they would tell you, because I mean, they're like, see, it's stuff like this that gets my goat bad. I can't even. No, when you see something where they have to come up with this 600 degrees Celsius oxygen-free environment, and it made metallic iron because apparently that's the only thing that can magnetize, therefore, and it's just assumption dropped in there, as opposed to going, well, magnetism is created by electricity, therefore. Like that's real clear science to me.
Yeah, you would think that would be the first thing they say is, well, there had to be some current here to create this magnetism. So let's investigate that. But nowhere does it come up anywhere about electrical current of any sort. And it never does.
It's kind of like they want to make it so far away. It's always like over 3 billion years ago, and those ancient eruptions. And it's just the words and the way they frame it.
Well,
something that might be much more recent.
Yeah, they have like a handful of samples of rocks, and they've determined all these years, time durations, and then you just throw them around as if that's settled science, of course.
Right. Yeah.
And all this is based
so beyond
off
anything that you could possibly comprehend.
Well, yes, because unless you realize how they gauge those numbers and then what assumptions they made from 1950 to now to get these numbers, because before that, we certainly weren't breaking rocks apart and gauging their age by their isotopes. We didn't even know what isotopes were until we started dropping bombs on people. A scientist did, sure, but I mean,
go along with that.
you know what I mean, in the grand mental scheme of things, where it became popular after certain events. I mean, even the sun was unknown what it was. We thought it was just, actually, we had no idea besides campfire in the sky until Eddington came around and grabbed the idea of radium and the idea of gravity, smushed them together in a black box, shook it, threw it out, and said, "There you go." And we were like, that has to be it. And that was it. We just, from like 1915 till now, we just sort of went, I guess that must be true. And it gets me every time just thinking about it, because besides talking to your father, Robert, last on Tuesday, besides him and his idea of the age of the world, most of us have an idea that we don't know how old the Earth really is.
Right.
I mean, the moon or anything like that. We're not saying it's like biblically young, but we have no idea when this happened. This could have been, something that was caused by something that, like one of those transient lunar phenomenon, happened sometime in the 17th century. That could be when that's from. We would not know.
Right.
I mean, the Earth got
Very, very
smoked
cool.
in 1908, and 1850 before that, and 900, and then 525. So in that length of time, the Earth got hit with this many probably cometary debris. Well, what about the moon? And there's been stories, just in human memory about strange things happening across the moon's surface. People watching it and going, "Did you see that? I saw that. Yeah, that." Sometimes they were as quick as sprites. They were there and gone. In a flash. But other times it was like the whole surface of the moon looked like it was deformed. And because they're looking at fire in space, it follows completely different rules. It doesn't not like an Earth, just like when they exploded the nuclear bomb there in orbit. They said, "Oh yeah, it's going to look like a big round explosion," and it looked like a ribbon. It just looked like an aurora. That's all it looked like. And they were like, "Huh." Well, I wonder what that was. Oh, well, don't study that. Move on. It'll ruin our special effects if we make I just wonder how much is reinforced. That's all I meant. Like popular culture reinforcing this, and and popular science as we're.
Does anybody know? I'm kind of ignorant in a lot of ways around EU theory, and especially when it comes to like the planetary alignment, the Saturnian theory. And I'm just wondering, is there a good theory in EU regarding the moon and where it came from? I mean, was it expelled from Saturn or from? I mean, is there a theory about that? That's
I always wondered that, but no,
I've read a few.
Is it assumed to be captured in Earth's orbit or produced in Earth's orbit? I guess is where I'm coming from.
In my understanding, and I've read Janot Cook's work and other people, SaturnianCosmology.org, and there's other hypotheses like the Ganymede hypothesis from which is a little bit onto one side, and then you go into more Velikovskian areas, and you have different interpretations of when things showed up. But one of the things that seems to be true is that the moon was responsible for destroying our rings. It was clear that the Earth had rings according to descriptions, and that those rings were seen by all the people of the Earth, and they were either 7 or 9. It was considered if you were in the northern hemisphere, it was where the dead went, out past this river. If the shadow of the Earth was in it, it looked like a hooded man with a sickle, because if it was nighttime, you would see the shadow of the Earth would go across the rings. It would just be dark. But the glint of the steel, which would be reflected right by your eye, would go by the Earth, hit the rings, and come straight back at your eye, like you're looking at wet dew on grass. You have a halo around your head, sort of like that. So this shimmering right there would come right back at your eye, and you would see it sort of glint like steel. It would sort of shimmer every night. You would see this, and this is the boatman that you had to cross. This is the river Styx that you had to cross. These are the seven seas. We called the seven seas long before we called seven oceans. Long before we even knew there were seven oceans, we called things, out past the seven seas. There's a song called "The Seven Seas of Rye" by Queen, which is like ancient. It has nothing to do with actual water. It's apparently a sky thing. No, at some point, and I'm not sure exactly when, the Earth apparently has moved orbit several times. It has a tendency, I think, to move outwards. And we have moved from approximately 260-day orbit to approximately 360, 365. There's been, this has caused, floods and all this other wonderful stuff that they've been talking about. I don't want to go too far into it. But one of the things about the moon was that we arrived at the moon's orbit and we started circling each other, which seems apparent. The moon might face us, but it's certainly orbiting the sun. It's not orbiting us. We as a pair are orbiting the sun. That's why it goes up and down in the sky. Unlike other moons of other planets, almost all of them orbit along the equator, where the rings are of Saturn, for example. So all the moons would be in a line, across the sky. But that's not the case with our moon. And also our moon is huge compared to relative sizes of the other moons of other planets. So apparently Luna showed up, the beautiful goddess or whatever, and the rings, it destroyed our rings, just dissolved them. And, they would no longer be able to be there because of this up and down motion. And obviously it's disturbing the magnetic field, and the dust swept away, I guess, or fell to Earth. I'm not sure. It could be where the dust of the Sahara came from, for all I know. So, but I think that was parts of the debris that were blown off of, Mars and other surfaces as well, us included. So that's an interpretation, but it seems to I don't want to say it feels like, but it taken all of the information I've seen, it seems one of the better hypothesis to it. So.
Well, that's good. So, am I understanding right? You're saying it's a capture then, based on that theory? I mean, that it was captured and then swept away those rings, that dust in the rings, either accumulated it or forced it to disperse. I
think that I think there was a time that the distance between the sun and the Earth was we were closer. So let's put us somewhere around Venus's orbit, and the 260-day orbit, and the amount of debris between the sun and the Earth was such that the sun looked red, and that the skies were kind of purplish. This is why probably it didn't clear up until like 2,200, 2,500 years ago. Even the ancient Greeks said that they couldn't see blue, and I don't think anyone could see blue because blue is something that we needed this pretty bright light. But if the sun was a dull red, this could account for that. Plus, also, we moved away through celestial mechanics, getting jostled by the clash of the Titans. Jupiter, Mars, Jupiter and Saturn having a fight in the sky, and that kind of thing. I don't know exactly if this even happened, because you go talk to someone else, and what's his name there, Vens. I can never pronounce his last name, but Renz, he has a different theory where it doesn't require the Saturn theory at all. But at the end result is that the planet still moved, and we saw we still see some of this what's called the zodiac light today. If you go to a really clear area away from all light, you can sometimes see a shimmer across the disk out towards Jupiter, for example, and this would create the shimmer of light is sort of like a reflection, as if it was across an ocean. But it's very, very faint now. But apparently in the past, it was much more prominent. This gives me the idea then that if you go back even further, that there was so much dust, it was occluded. The sun was somewhat occluded from all this, material being blasted off by, the Clash of the Titans, all this other, destroying parts of Mars, blowing Phobos and Deimos off, creating that big rift, that type of thing. Parts of us getting hit, all that stuff. All this debris was up there. But only recently had it, like in the last, say, 3,000 years, had it cleared up. And we showed up at the moon, type of thing.
Yeah.
And the moon cleared that up, cleared up the skies around us, and a lot of, and this is my, trying to understand this, of course. This could all be total fiction and I'm making stuff up, but I'm trying to, I've read so many different points of view on this. This is one of the things, though, that seems to be a constant is the moon. We don't know when it was before this, but we do know that we showed up on its orbit. So we moved to it. So we moved to, it could have been orbiting at 365 days, happy as a pig, or whatever, 360 days. And then we showed up and then we pushed it out to 365. We grabbed a hold of it and sort of made it rotate around ourselves in this. And we've been together ever since, so to speak.
Interesting.
It seems like a lot of conjecture to me.
It has to do with the interpretation of myths, right? So, and that's the that's the problem.
Also, I mean, not to disclaim myth because that's my favorite part, but
of course.
To also say that the water cycles are so heavily dependent on the incorporation of the moon or the moon's effect on us. I don't know how realistic it is to think that all of this functioned in the way that it does without that ballast. First. Second of all, I also have a hard time with we've talked about this before, about the color of the sky being a different, like not being able to see blue. When you're doing color differentiation testing, with the Munsell color wheel, they give you little chips. And the chips are very, very similar in shades, and you have to take the chips and put them in chromatical order, like going between this one and that one. And some of the hardest to distinguish are the turquoise colors, the blue-green, and the periwinkle, a blue-purple. So also, purple was seen as a different color from violet. So all of these things really make me question. I mean, because I'm for it, right? I'm for planetary reconfiguration. I'm for Saturnian cosmology. Like I've read enough and seen enough to say there's something to this, definitely. But the moon part has always kind of gotten me in that our planetary functions are very dependent on the cyclic nature of the moon's orbit of us. So
this could be totally wrong.
Been very different then. Well, but if we could hypothesize or try to think about what life on Earth would have been like from a water cycle standpoint without that ballast, that might help us understand when and where the moon came from.
Well, are you referring to the tides only, or are we referring to something else?
Well, not just the tides, but the plants are dependent on the moon. Anything that's got water in it is tugged on by the moon. Women have their cyclical cycle according to the moon. Like when you plant seeds, you want to do it between the new moon and the full moon. Or sorry, the full moon and then you want things that go underground to be during the new moon period, and things that are going to be above the ground during the full moon period. And there's a lot of dependency on that cycle within the metabolism of living things.
You're right. It's like very. It seems fundamental to what we've evolved to be. So it's like ingrained in our evolutionary from way back from amoeba stage or whatever we evolved from.
We have to be fair, though. We're number one. We're really adaptable, but. Until recently, I didn't even. This is me regurgitating stuff, not even taking into consideration. I'm still adapting to this wonderful idea that the pole has actually moved. That we've moved. That was Mario Buildreps, I think, his work there with the the moving of the pole and all the monuments. putting that into mental context and to understand how that we have been building stuff on the Earth for hundreds of thousands of years is, I didn't even cope with that yet. So I'm just with the Saturn crowd, which could be in the, it's more compressed, but this could be a much longer time frame. We really don't know. And I'm comfortable with saying that, the moon itself is I would think by the stories that there is something to them, that it showed up, it's something that it said showed up, like the myths imply that, or at least either imply or directly state it, which I think that would imply that we showed up to it. It didn't show up here, because we were the ones that were going through the tumultuous time and actually moving. It seems, the water rebalancing, and it seemed to come just after the Great Flood type of thing, which would have been one of the many, apparently. But there was this: the water would have had to rebalance if we were actually in a polar configuration, and of course, flooding massive swaths of area and so forth. Because some of
what was the thing that Peter was talking? Peter was talking about that crater. Because just to get back on the line that Andy was going with the crater, and just reviewing and kind of building a narrative around what happened there. Do you remember that crater that we were looking at that had that like direct line? It was that's like a Pisces. I'm just wondering what Andy's interpretation of that would be. I hope I can. I don't know if I can find it. I'm putting myself on the spot to find it.
Are you talking about the swirl that we were looking at in the beginning?
No, it's
a different one.
It's a double crater where like the line separating them is almost like a perfect line of symmetry.
Oh, the side-by-side one with the line in the middle?
Yeah. Mm-hmm. Yeah. Let's see. Double crater, maybe. Yeah, there it is. Good.
Oh, these.
Yeah.
Oh, when you said Peter, I was like, what? And now I remember exactly.
Mr. Venus.
Doublets.
Yeah. Do you see these when you're playing around with plasma arcing and into like the article that you wrote?
What I see, I see rim craters. I see rim craters on Earth. If you're asking, on Earth, I do see rim craters, and I also see, landforms that are two sides of, a positive and a negative side of a circuit. They don't come together. They don't form. I haven't seen this kind of a thing, like a doublet, just like this.
Mm-hmm. Mm-hmm.
And I think that's
really interesting.
I think that's a big difference between a planet that has an electromagnetic field and an atmosphere like we have, and an atmosphereless, dead planet like the moon. That I think there are differences in these, especially these kind of features, crater features, that the electricity, the circuitry is different, because
Mm-hmm.
we have the internal circuitry of the geomagnetic field and a layer of atmosphere that's, a layer of capacitance in that circuit, which creates some different features here on Earth.
Okay.
But I see rim craters all the time. And that's in volcanic fields. You can find a lot of rim craters.
Mm-hmm.
Well, the thing that I think that we were very interested in was this line, or these lines that are direct, which in my mind imply simultaneous creation.
You mean on the sides? Oh, I see. You can see
it's perfectly straight, or
more
or less,
almost
on either side of the figure 8. And shooting, I've never noticed that. This is a great resolution. I've never seen that before.
Yeah, and they blow out the sides like if you can see that they were. It's like material, like two zaps came in.
Like Jacob Gable's work, where like when power goes out, it degasses it, or whatever flows out. Like
implying that these two things, this was virtually simultaneous, and that the winds that it created, such as they were, or whatever dust it all shot out horizontally.
And
Is that what?
Yeah, exactly. And there seems to be in this image anyway, a predominant flow of wind afterwards. We'll call it ionic wind or whatever, because you can see how they have these two slight half moons in the bottom of the crater. That look like, those just at the bottom, which sort of imply a wind going from either right to left or left to right. I can't tell.
Interesting, because those half moon figures, you find those in the bottom of Mars craters. If you go look at, like last week we were looking at the Pinacati, and we were looking at some of those craters. They have features exactly like this in the bottom. And they're features that you can see because the vegetation changes. I don't know if you want to go look at those. Yeah. You can stay on the moon if you want. But those half moon type shapes in the bottom of Pinacati's Mars craters, is almost every one of them has some shape like that.
Okay, that's good to know. I actually never tried looking at them only because I guess I've been sort of looking at beautiful craters all over other worlds. There's some other good moon images that I would like in that exact picture there that we can talk about after we're done here. Because there's some others that, as Robert pointed out,
where we were last week, right?
Yeah, right in that black spot. I think it's more south.
Oh, okay.
You can go. You can go to Cerro Colorado there and zoom in, and you can look at the bottom of it, and you see that light crescent in the center. Excuse me. And that light crescent, of course, that's the very low point, but it changes the character of the soil and plant life and everything changes across that feature. And then if you go to the other craters, they all have, every single one, the other Mars have some feature like that. And almost all of them have a rim crater like this one does, which is right where your cursor's at.
Mm-hmm.
It's got like a nice upward spiral, like tilted spiral happening. So one side of it's a little higher than the other too.
Yeah. If you go to your, I always put like 2 or 3 times the height on the elevation profile. It helps things stand out a little bit. Elevation.
Oh, okay. I'm not sure how to do that.
Do that. It's in the properties or settings.
Okay. All right.
But
I'll look at it. I'll look at it for next time. We could be after that for half an hour, So.
Yeah, it makes elevations a little bit out of proportion, but when you're looking at mountains like this, it really makes them pop out a lot better.
Right. Yeah.
I think the other crater that you were talking about is from this to the southwest of this one.
Yeah, so if you want to scan around, there's actually 10 more craters like that, and they all have, we don't have to look at them all, but they all have those features in the bottom of one kind or another. So you're right over El Elegante, the one just below your cursor right there.
Yeah.
And there it has its feature in the bottom. And this isn't like just playa, where it's just like, well, that's where the water settles and that changes the character. It's more to it than that. Soil's different, plants are different, everything.
Again, it's got that spirally to it with like this. It's almost like the accumulation of everything that was lost in the surrounding area landed right in that center of the spiral. See it?
Yeah, it all spiral. Yeah, it all kind of like swirls into that.
Mm-hmm.
So now if you back up on the other side of the volcanic field, I'll show you one. My favorite, if I can find it. So you see these, there's some more Mars craters. There's a big ring right there.
Yeah.
Yeah, right there. And it has that feature in the bottom too. This one has, see the rim crater? This is interesting because it has the rim crater over here to the right. And it also has a crater inside the rim.
Right.
Which is kind of weird because that little crater has a tuff ring around it. So that must have happened after the big crater was formed.
Mhm.
Which, but then there's no ejecta from it around there except for the tuff ring itself. I mean, if you just think about it, just look at that. Zoom down on it a little bit closer, the rim crater. And you see the tuff ring that's in the
other
bottom.
one, I think.
No, on the other, to the right.
Okay.
Okay, right there. Zoom in, right? That's the rim crater.
Mm-hmm.
Okay. And to the left of that, you see the tuff ring inside the big crater. Scan to the left.
But now to the south.
And
All right, yeah.
there, that ring right there. You see that ring by your cursor? Right there. Exactly.
Uh-huh.
That's a tuff ring. So that had, I mean, I assume just visually that had to have occurred after the main crater because it's sitting in the floor of the main crater. So if that was a blowout after, where did all the ejecta from it go? Except for the little tuff ring around it, there's nothing that appears to be the ejecta from that volcanic eruption.
So almost a falsification of the volcanic origin of this crater, really.
Falsification of the existing theories.
Yeah.
There's several theories on Mars. They're not understood well, and they're still developing theories. They have an hourglass shape in there down below, and they can't quite figure that out because they compare the rocks around it in these tuff rings, and they're graded size and depth that they came from, and they're all mixed, which shows that the whole pipe blew out all levels at once instead of being graded with the surface stuff on the bottom and then the deeper stuff on top of it. It's what you would expect in a blowout. It's going to pop the top off first and then blow stuff out the bottom on top of it. And they find it's all well mixed, like it's blowing from all levels in the pipe beneath it at the same time. So they have big puzzles about how that could happen and theories about how that could happen. None of which I think are very good theories. But if you introduce electricity, it kind of becomes much more plausible to understand all that.
Oh, yeah, it looks like it basically, especially with given the landscape beside it and above it with the mountain range.
Now, right, I'm sorry to interrupt.
Interrupt.
I'm sorry to interrupt, but I just didn't want you to scroll away.
Sure. Right
next to that, see the funny shaped craters right there? Zoom in on your cursor now, and you get these weird shaped craters. Now, no, down. Go down.
Okay. Oh, right.
Where your crater
right there.
cursor
Right there.
was, yeah.
Yeah, go right down on those.
They look
Now,
almost the same.
This is a well, actually, it's a triplet, okay, or quadruplet, because there's one up above too. It's a little set of craters. Now, the crater floors and all these are the same level, which I think is pretty cool. Now, if these were separate events, completely unassociated, different eruptions, but they're not. They're obviously, it's the structure look at the rim between the craters. I mean, how did that happen from a simple eruption from below? It just doesn't comport with common sense.
One of them would be buried.
Yeah, one would bury the other if there was unless they happened all at once. But if it happened all at once, how does just simple volcanism explain that? Because the Mar crater's explanation wouldn't explain those shapes. Not any way that I can conceive, anyway.
Electrically speaking, this makes a lot of sense. I mean, if I was to look at this rock just from a cursory thing, I would say that the darker rock has more metal in it, just straight. Just looking at it, I'd say that the stuff underneath is either pure sandstone or something of the sort, silica. Now, if you note, the craters seem to attach to what could have been piles of this stuff from either actually ejected from the thing or otherwise transformed across the landscape. Who knows? But it reaches in and then gets to a certain point where it goes, all right, I can't get any more from this because there's literally, this is the middle of this material is non-conductive. I don't care about it anymore. I want to go to the rim. I'm going to go to the rim and get more, because I want conductive material to get these electrons from is what I'm going for. Whatever is causing this event. This is generally what the electricity is thinking, so to speak, And when I see stuff like this is sort of like a finisher. Like it's going in, it's ripping up the land, it's going for this crater, but it can't dig through this stuff because it's going to go more to the rim now. It's going to go to the darker stuff, looking to get more current. But as you can see, this is just the trailing edge of a much larger event.
So let me show you one more before we leave this.
Sure. Yeah.
This is my favorite one. Now that you've seen those, okay. So if you go back to the area we were in, but a little bit to the right about where your cursor is, okay, go down. Now go to the right. Wait, stop.
Okay.
Not too close. Okay, go to the right. Just scroll to the right. A little bit more. Okay, stop there. Pull it down a little bit and see that. No, down.
No, this way. Okay.
Yeah, just stop. The one just to the left of center, that crater, right? Okay. No, that's a right there. That's the crater. Go down on that.
Okay, I'm super fascinated with these horseshoe shapes too that DJ keeps trying to stop on because I know he's trying to figure out what they are. I want to talk about those.
At some level, I'm attracted to other things, but
I know.
Please direct me because I it's like bridling a horse a little bit. So.
Now, this is my favorite. It's the delta Y.
Yeah.
In the bottom of the crater, that's a delta Y.
It certainly is, and then it's even got the delta around it. So.
And that is totally natural. This is out in the middle of nowhere. I mean, nobody went out there and built that pathway in the middle of this marked crater and lined it with trees. It's just a natural formation.
Wow.
That is pretty amazing when you get right down to it. Perfectly, the delta, excuse me, I can't believe I just burped. Delta Y type of thing. Right in the middle of a crater.
Yeah, which is the classic way of connecting an ungrounded system to a grounded system, like on a transformer. And that's what we use is a delta Y connection.
Right. I mean, it's hard to immediately think that could happen, but breaking into threes is actually fairly common for plasma. We've seen this in the Isle of Man flag, which is done. It looks just like that. If you looked at the Isle of Man flag, which is very odd that it does look like that, but it's sort of like a three-pronged version of the swastika.
Well, that's a very common symbol.
Yeah.
That is a very common symbol, the three-pronged wheel. Mm.
So I'm just, it is a, just like 3s, 4s, and 6s are things that electricity likes to do. I'm not sure why. Not sure why at all.
We've got one thing we ran into. I'll just share it really quickly. But it was like going back for simplicity and looking at, because a lot of this stuff, you perceive it as like particularly electrical events with all the frequencies, et cetera, and what are harmonics. But I ran across this. Let me see if I can run it real quickly. If I can get there. Yeah. Here we go. So let's see if we got anything. Am I running? Yeah. Okay. So I got it cleaned up a little bit, Heather. So basically, this is a multiplication table, believe it or not. So I'll explain what's going on with it. I'm just breaking a circle down into 180 the positions. So theta is of the entire circle is broken up into 180 pieces. And then you just go along the edge and multiply out. You get it's like 0 to 1. So you go to 1, and then 1 times 1 is 2. 2 times 2 is 4. 4 times 4 is 8. So that would be one level of the multiplier on it. But it gets some pretty interesting things as we go up into some higher levels here, and I'll show you kind of the dynamics that we got. And it's just like, if you start looking at something very, very simple, ends up can get real complex real fast. But, hinting at some of the cymatics things we've been looking at. And let me slow it down a little bit here so you can kind of enjoy it a little better. Let's see. I toned it down so we can get that down there. Let's see. Here we go. Okay. So you've kind of probably seen this with string art, etc. But there's one of the things we're looking at. We had a conversation with Richard yesterday, and we're looking at the relationship between the planets and the sun, angularly, if you were looking, from above the plane of the solar system, and you start seeing patterns that are very similar to this. So anyway, it's kind of it's a bit of a toy, but it's certainly interesting to take a look at. I'll go to just the single numbers here, but you can kind of look at. Let's see if I go. You can see the Mandelbrot set in here too. So one ends up being just a circle, but here's 2. That's what 2 looks like. Okay. This is 3. It's 4. So it's always n-1 as far as the nodes go. And 5, 6. So you see these symmetries that come out of it at these whole number of positions. 7. Let's see, 13 will be 12. So you can see 12. It follows this n-1
right
symmetry. So as you get, go ahead.
Sorry, send me that one. And can you send me that one, please?
Sure.
And what about the 15 one? Can we show them the 15 one, or whichever, the one that had 15 outer nodes?
Oh, okay.
When you would do that,
would be
16?
Yeah,
16.
that would be 15. But it's n-1,
right,
as far as the symmetry goes.
This is different shape, but this is, oh no.
I think the one we were looking at yesterday was that one. Okay. Oh, wait, maybe not. I'm wrong, probably. 17. No. I see. I wanted to get it so we could get the ability to scan it, and find them. So I could put an upper and a lower bounds on it. So I put like upper would be 70, and then the lower, let's just say 50, right? And then I've got it so we can change the rate. Let's see, kick the rate up here.
We were talking earlier how just strings and geometry were able to show how a lot of ancient monuments were built, or at least surveyed, which is actually not very different the way that we used to do it. So it's almost like we just picked up and continued on.
Right. Well, once again,
patterns.
Really cool.
Yeah. It's cool, isn't it? Yeah. Oh, I got the outer one up. Let's turn that up. There we go.
I think that you're probably hitting on something, because there's a nature, there's a limits to what like electricity is going to find. It's going to be rarely. It does too all the time until it starts interacting with things, and it sort of like starts subdividing. I'm not sure exactly how it does that or why, but I know why, but just the nature of how it will go. Okay, I'm going to go into the top pole of Saturn, so I'm going to be, a hexagon today. we're going to do, and of course hexagonal craters and so forth, are common. Those dual craters are very interesting, but sometimes we see threes. They're a little bit rarer, but we do see those. It's just very interesting. Certain characteristics lend themselves to a pattern that it can flow through. I guess easier.
Mm-hmm. I mean, this nodal nature. One of the things that kind of brought me into the group was Jim, discussing his model, and then my exploration of it, and you start seeing these harmonic relationships pretty strongly. It's really fascinating. Yeah.
I really love the fact that all three of, just for example, Jim, you and I are all looking at this through a different thing, but none of us are at the point where we're going to start screaming at each other and saying that my way is the only way.
Oh, right. Well, this is where all this, and this is where all this the conflict comes from. It's like get yourself out of the picture. It's fun because you become. I'm playing with toys ultimately, and it's like, this is a really cool toy. I want to share it. It's like
Yes, Andy. Jim.
It was inspired by someone else too. So.
Well, of course. But Jim is into astrophysics there, Andy, and he has he works with Bessel functions and orbital mechanics, and trying to understand the nature of our local interstellar cloud and stuff like that, trying to understand how our solar system works its way through the galaxy and stuff like that. So he's touched on a few things that belie a larger structure to the nature of the way that the solar system works, which is not necessarily related to the Saturnian theory, but at the same time very much hints at the electrical nature. And that's what, I mean, as long as we're talking about the electrical nature, or the fact that the current science ignores the electrical nature, we are brought together. So,
well, I see what in my last series of articles, I think it was the last one I put out, where I talked about charge diffusion and in the canyon lands. I presented one canyon feature that looked very much like the Mandelbrot set, and how charge diffusion takes place. There's a mathematics behind it, and I think that's what these fractal forms emerge from is the mathematics associated with charge diffusion, and that's right. When we see images like this too. I think it's because there's of like the Mandelbrot said, and I'm not a mathematician, but the equation involves imaginary numbers, right? And I think I think that what's being described is the motion of diffusion and absorption as it progresses, because as charge progresses, it's either going to get absorbed, combined, or it's going to keep moving. And these mathematics get to the heart of describing that diffusion motion.
Right.
And so
you start thinking of the vibratory nature of everything, and then the spire of the spectrum of frequencies. Then it starts making sense, and you start drawing things with it.
And so you see harmonic
model.
Yeah. So you see harmonic repetition of the same forms at different scales.
Right. That's very cool.
And mathematically, that's called diffusion limited aggregation. So it can grow, and basically it's pressure and the release of pressure is ultimately what you're talking about, correct?
Yeah, basically it's compression and expansion. Yeah,
compression and rarefaction. And that pattern is what a Birkeland current is. It's the same. It's the same thing, just drawn out upon vast light years of distance, and so we can see like slices of Birkeland currents by looking at the poles of Saturn, and real time leaf-like slices is what we look at and see the hexagon inside of the Birkeland current. Sorry, I get excited with this stuff. And
no, I think this is the core of science. This is what science should be looking at and understanding this, diffusion properties and recognizing it, because the patterns are recognizable. The fractal patterns, the harmonics, these things are identifiable and predictable. And this is the heart of science. And it's verifiable visually. It's the stuff, that we can do in the lab at a smaller scale. The changes I see are all like emergent phenomena. Like if you take what's going on in space in a force-free vacuum versus what's going on in the atmosphere in a not force-free environment where a lot of particles are colliding and discharging is going on, arcing's going on, you get differences and you get hydrodynamic effects and things like that take place, or solid state diffusion within the Earth's crust.
And we have to be fair to geologists. We're talking about things that could only be described as biblical or even worse. In some cases, to imagine what is happening on the Earth it's almost beyond the realm of imagination. I mean, if you told me that until I actually saw a crane, and I only saw pictures of it, a crane touched a power line, and it had its 4 little feet down, how cranes have those arms that will attach to the ground and sink right in. They're made of metal. So it touched the power line, and when it did so, it was thrown 50 feet into the air, because what had happened is that so many electrons were asked by the wire and it flowed very, very freely through the metal objects, and the crane itself, that it left 4 10-foot circular craters that were conical in shape, and it so asked for it so hard that it pushed those up, and as such pushed the vehicle, which was a 50-ton crane or whatever, into the air 50 feet, and it slammed back down. It was no longer touching the wire then, and the guy that inside did live, but no one expected that, because you don't really think about it. But that's just the power grid able to move a 50-ton thing into the air, and you go, yep, choo, you're taking off. Well, if that can happen, then we're talking about, magnitudes beyond that, able to rip up landscapes. It's just not something that should have popped into the minds of someone from 1880. It's just, I give credit where credit is due. They're trying to be reasonable. This almost seems unreasonable until you understand what you're actually playing with.
Neil, what you said is beyond biblical. I actually use those words
beyond biblical
in the draft article I'm writing now, because what happened is beyond even the crazy biblical descriptions.
That's when things were calm. When things were calmer, like people could have a society walking around and things were seen to be okay. But before that, things were even worse. At times.
Before that, things were even worse. And I can show you guys if you're interested.
Please.
I can show you exactly how bad it was. And I can show you also absolute proof of electric universe creation of the Earth. You want to see that?
Yeah.
You want to see some absolute
Yeah.
how it really was?
Yeah.
You've seen it here first.
Okay, we need some pictures of Jupiter. So if we've got some good NASA shots of the Great Red Spot and nearby it.
Some were just beautiful, released recently, that were just hypnotizing. You could see
Absolutely.
the depth.
Some of the Juno, if you get some of the latest Juno shots of the swirls around Jupiter, it's they're in and around the Great Red Spot, especially.
Yeah, just some. Ooh, hello! Look at those.
Now, what I want to show you is we want a picture. Go to the one that's to the on the second row down, the second from the left.
That's the one I
Or
thought
that one you have your cursor on would work. Well, either one of those two.
Okay.
It shows the swirls that are around. Yeah, that's a good clear one.
By the way,
Now,
that's Io, in case anyone's wondering. That's the shadow, and the moon is Io. So.
But what we want to look at are the swirls down below the spot. Look in those in the turbulent area there.
Uh-huh.
Now, what we need to do is, if we can keep this so we can toggle back and forth and then go to Google Earth. Can you do that?
Yeah.
He's a master. He can do anything.
No, I'm not a master. I've got some practice now.
Hey, remember what we used to do before, trying to figure it out? Yeah, this is, you're a master. Yeah. We're good. We've got this. We've got this.
Yeah. We need a backup, though. Got backup character.
Robert's learning. He's good. He's good.
It's true. Okay.
He can do this with a phone. He's like, I can do this.
Somewhat.
Well, hey, I'm not going to argue. I just I'm watching volumes and keeping things running, and so.
So
am I following you, Andy? Google Earth.
Okay, yeah. So let's go down to Mexico.
What's with you in Mexico?
I love Mexico.
I'm just
okay.
It's fun.
Okay, you're centered perfectly right above where it says Mexico.
Okay.
Zoom in on that area right there, the mountains right there, exactly there.
Okay. This whole.
So that
whole swirl there, that
Torreon to Monterrey area.
Yeah, go down where it says Nueva Leon in Monterrey. Go right down, zoom in there a little bit closer, and I want to show you these mountains.
Oh wow! Right.
Okay, now get in closer.
Kind of reminds me of the Appalachians up the East Coast, kinda.
Okay, now scroll up and look at those shapes right there. Okay.
Oh wow!
Zoom in on those. That Sarah, yeah. Zoom in right on that big crater. That's what it is. It's a crater.
So there's a mountain inside of it.
Yeah.
Lanans, I guess it's called.
Well, that mountain with a crater inside of it. Now it has buttresses, triangular buttresses around it.
It does,
ringing around the side of it. But looking to the left, I'm talking about to the weird leaf. I don't know, what do you call that? Donkey ear feature? I don't know what it is. It's look inside that. That's a crater, and that the rim around it is all triangular buttresses pointing outwards.
Mm-hmm.
Okay. And go in close just to look at the crater sides, the rims.
Yeah. Wow.
Whoa, yeah, you can see it right along the southern border there.
Yeah, you see?
Yep.
Wow.
Those are triangular buttresses. Shock waves, right?
Look at that.
Can you head over to the...
Amazing.
Isn't that amazing, that structure?
That's totally amazing, yeah.
Okay, now go back to Jupiter and I'll show you what made it.
Okay.
I bet you're gonna show me why I think Jupiter is has a solid surface not too far below this.
Yeah, under the spot, I think there's a solid surface.
I think there's probably like a windswept mesa. Almost.
With mountains.
Oh, yes, with mountains.
Now, zoom in again on that turbulence down there.
Down here?
Yeah.
Yeah.
And these are the forms we're seeing. Now we're seeing the cloud tops, whereas now zoom in right there, exactly where you had go right to where you had your cursor and zoom in right.
Sorry, right there.
Yeah. Well, down a little bit lower, just a little bit lower. There's that I-shaped thing. There's a tornado right there.
Yeah.
Right on top of that. Zoom in on that if you can, as close as you can get resolution. Okay. So that is what's forming that shape on the ground. That's a cyclone with a downdraft wind, and that hole in the center is it's like a hurricane, a cyclone.
Mm-hmm.
Downdraft wind down the center. Hurricanes have the eye of the hurricane is a downdraft wind. And that is blowing against the land in exactly that shape. And it's creating the rim crater in a donkey ear shape like that. And that's what's creating those shapes. And if you scan around, maybe back up a little bit because the resolution's a little blurry.
Right.
As you look through the clouds, you see those shapes all over the place. And if you just go straight to the right there. Yeah, scan over that right there. There you see an area where there's a whole bunch of swirls in the center of it, and it creates a great big. That whole area right there, you see 1, 2, 3, 4, a whole bunch of swirls inside of it. That's creating one of those odd-shaped craters on the land below it, assuming there's land here. But that's what happened on Earth to create those shapes in Mexico. Now, if you go back to Google Earth, we'll go look at some other features in similar type of terrain.
I see that some of them were clearly pulled together at supersonic, as you can attest by the shock fronts and the buttresses. But clearly, after that, we're still being carved slightly by not necessarily supersonic winds, but obviously electrical winds still sweeping through the area.
Yeah, you can see whether they were supersonic or not, whether they left the shock patterns.
Exactly, like Tent Rocks versus San Rafael Swell.
Yeah.
So they recently this week released an article about Jupiter having a third pole, much like the South Atlantic anomaly, where it doesn't favor the South or the North Pole. It's kind of a polar anomaly in of it, itself. And they didn't directly say it, but I was like, where is this placement in regards to Jupiter's Great Red Spot? Like, is this the visual, the like straight up visual physical representation of this? And they never said anything, but if you layer them on top of each other and you kind of look at the placement on a sphere, it's very similar and they do say that it's in a similar place on Jupiter as it would be on the sphere of the Earth for the South Atlantic anomaly.
Yep.
So it makes me wonder if, like, to support what you're saying, if this is because our poles move or whatever, with all that, if at some point that anomaly was closer to where these things are occurring, or if there was some sort of extra Earth spot happening.
Well, didn't they? I may have seen the same article or one about the same, and they mentioned a blue spot.
Yeah, they called it the blue spot as opposed to the red spot. Like,
yeah, but is it in the same spot? I couldn't get that out of the article either.
No, they don't say it. They don't state it. I'm thinking they're waiting for that to be their next big announcement.
I certainly suspect that the Great Red Spot has a plateau beneath it, and I can go through that too. I mean, as to why I think that, but that's coming. I'm writing an article and hopefully can at least give my thoughts about that. Mm-hmm. Back up. So you see now what's going on here. Okay, to the left there, those features we were just looking at are craters, and around them you see the lenticular mountains, and those are the updrafts. So what you have in this turbulent zone is you have winds swirling right and left, back and forth, but you also have winds diving down into these cyclones and then rising back up in clouds in updrafts. And this is the same thing that happens in normal weather, except to an extreme extent. What we see in thunderstorms and cyclones right now today is the same updraft and downdraft blowing against the land that the Jupiter's turbulent area is doing. It's folding these winds up and down as well as back and forth and creating mountains and craters alternately. And the swirling pattern of all these linear mountains are formed like sastrugi. Those are, sastrugi are formed in ice, and they form parallel to the wind. They form linear shapes like these. These are basically rock stratugi, or stratugi formed in these winds that created these craters and mountains. So another area we can look at, this area leads upward north towards the Colorado Plateau, which was where the Great Red Spot on Earth was. And it sat over the Colorado Plateau, and these were unipolar winds driving north from Mexico and creating the terrain. And so you see that whole swirl is a fractal repetition of these smaller swirls within the clouds that you see on Jupiter. It's the same formation.
Yes.
So now go to like Iran and Pakistan.
Wow.
Actually, they're very similar. I mean, just by the beautiful curves of the rocks of it.
Now, overall, the picture, as you see over to the right, the Tibetan Plateau and Tajikistan, the huge desert up there and all.
Gobi, I think it's called.
Leading to it, you see these same type of flow patterns, okay? Mm-hmm. So look down around the seacoast near Karachi.
Well, today I've learned where Karachi is.
And go to just to the left of Karachi there, and you see right where you've got your cursor, you see the shapes right there.
Mm-hmm. Oh, wow.
These are the same kind of craters.
Wow.
These are the same kind of Mount Strugi formed by wind patterns, just like on Jupiter. Now, this is visual evidence.
patterns, too.
Yeah, well, yeah. You see all kinds of other electrical things. You get in closer, and there's lightning strikes you can identify, and all kinds of other things.
It's one of those landscapes that you would use as an example of, like, if you stopped it right there and just looked, you would be very hard pressed to tell the difference between that image right there and if I showed you a lightning arrestor that has been struck and blasted off parts of it. You could tell the difference.
That's right. Yeah, the flame or pattern.
The flame outs and stuff like that, and the Lichen birds.
Curve away, magnetically formed.
Obviously, the supersonic winds, I can see the buttresses along the south there as they built up, and along that rim, though. And of course, these things, this is what, I have to think about what happens in real life when, like for an arc flash, as they call it, a very dangerous situation that occurs when someone does not properly or something fails spectacularly electrically, and usually with high current. It can happen at even at fairly low voltages, but usually doesn't. But if you start getting over a few thousand volts, you can get a very impressive situation, which is highly lethal. In fact, you have to wear special equipment if you're going to be at risk of it. And it does not stop the actual pieces of metal from flying through you. So that will still be trauma, but it will stop your body from being third-degree burned. And that's obviously what you don't want. But it happens so quickly that, like, once you see an example of it, it's just kapow. It's just that sort of instantaneous sort of explosion, the kapowishness, so to speak, is something I remember from thinking about Krakatoa or something, where it was like just the bang of it happening was so powerful that you could hear it on, in LA, and it took place in Indonesia, So,
heard around the world.
yeah, it heard around the world. So and that's just a volcano. So to imagine what this would have been like, and this would have been sustained, because this is not just a one instant event. Like something sparked it, and then all of these secondary currents, the things that we were talking about, Robert, when you mentioned when Jacob Gable turns off his power, and I discussed inductive kickback. Well, this is this right here would be sort of almost the result of the inductive kickback that formed the Tibetan plateau over there, type of thing. It would still take a while for all that to be processed, and of course all the wind that would be generated by that, and that would slow down and calm down, just little sparks and shimmers and a few extra little here's and there's, and then it would be like, then people would go, what the hell just happened? Because
Well, as you can see, the pattern there is just like the turbulent patterns on Jupiter. And if you scan along the coastline, along where this wind blew and these mountains are formed, you'll see more. There's some more there. Mm-hmm. Zoom in there near Nikshar, and you'll see a bunch of features there. Craters, and I call them craters and domes, because you have craters where the cyclones were, and you have domes where the uplifts were. And as you move towards the Tibetan Plateau near the center of the storm, or over the Colorado Plateau near the center of the storm, you find domes and craters as well, but they're not, they're part of the center of the storm. They're shaped differently. They're not strung out in linear mountains like this so much, because they're not in this ambient wind here is blowing in one direction. And in the center of the storm, it's a rotating wind.
Right.
And so you can see the differences in the landscape is what I'm trying to say. The patterns are all there to be seen. And this is a first level proof, if you know what I mean. This is visually, I don't know how you can better explain these features than the simple wind form pattern by looking at Jupiter and saying, aha, that's what's going on.
And when we look at, of course, Jupiter has an atmosphere, duh, and so do we. That's a big difference, because on places like Mars and the Moon, which are frequently our only two other, until recently, our only two other close-up views of things that we had powerful telescopes to look at, all these features are called, if we see them at all, are called rills. And there's not a lot of wind, but there's still material being moved, and you can see that there was some sort of movement of material across the surface of the Moon, and there's no wind to have done that. How did that happen?
And that's the difference. That gets back to the diffusion issue, and diffusion in an atmosphere versus diffusion in a vacuum or near vacuum.
And it has a big difference on the patterns we see. And I think, I'm very happy we have an atmosphere, because it's thick enough to resist some of this, because, that little barrier just below 1 mile that was thick enough or whatever to keep, to make that sort of capacitive layer, that barrier where they had to sort of punch through and rip, turn this from a global shit show into regional shit shows, I guess. Because you could happen over there and not necessarily happen right on top of you. So we had survivors, and we could tell the tales, I guess.
Well, the Great Red Spot has been there as long as we've been observing Jupiter. I think over
400 or 500
close to
years.
400 years, right? So
since Galileo,
when you think about like the Younger Dryas period lasted for 1,000 years, I could see a storm system sitting and swirling for hundreds of years like that. And it's it's wave guided because you have the magnetic signature on the Earth that these storm systems are patterned to. They're following what's on the Earth below. And once a mountain is created, then you create a point where ions are going to collect and rise and strengthen the electric field, and it's always going to be that way. So even today, when we see weather patterns form, we see them forming in association with the land that's below it, or the lack of land below it over the ocean.
Could you go back to that for just a split?
Oh, right there?
Yeah, okay. Right where you were. Down a little bit more to the southwest-ish, right? Yeah, just right there. I noticed those dikes, mountain ranges. If you can go where it says Sangrepier at the bottom. You can see that? Just a little bit right in there. Perfect. So it says Sir, I think. Right in the middle. Sir. Hi, Sir. Right there. I noticed, if you look, you can see these mountain ranges going up. But if you notice where it says Shinar, that's a negative version. That's a valley. If you look. Yeah, slightly, stop right there and go slightly to the left. Just, no, not turn.
I know, sorry.
I know, it's okay. There you go. See where it says Shinar there on the side? Up at the, no, stop. Right there on the edge. C-H-
Oh, with the C, Shinar.
Yeah, sorry. I should have said that. Chenar. It's right literally to the side of the screen to the left. Yeah, right there. You can see it right there. So, what I meant was if you see these mountain ranges, if it was electrical, you should see negative versions of that. And there you have one. Ripped through the landscape while these ones were built up through the landscape. You see what I mean? Material is moving along, some of it being ripped, and there's a loop. Some of these loops would probably be moving, I'm figuring, Andy, as they went across the landscape. And I can picture ripping from over where it's Shinar all the way down to where it ends in the valley, and then depositing it right beside it, type of thing. And in the same line,
Yeah.
That's and you're right. That could have it could happen instantly or at the time.
Yeah, there's a dike. See, that feature you can see running. That's what you were pointing to. That dike feature that
Sangrepier right up the middle there.
Yeah, runs right past Sangrepier, going up and down the.
We apologize to anyone who's listening. We are not pronouncing any of these right. Somebody's going to be watching this from Iran and going, "These people."
You're supposed to pronounce it without. You're supposed to pronounce it. It's the one below it. That's the one.
Well, I'll bet if you go in close on that dike, it may show buttresses, and it's probably partially buried, and that's like the top sticking out because usually when a dike forms, the wind will then pile like buttresses against it, and that's what that appears to be from this distance. Yeah, you can see look at the black line though. The black line is the dike that to the right.
Here. Oh, okay.
Yeah, right there along there. Now get perspective, kind of clock around, and you can see those are the tops of a windblown feature. Those are all along there. So a dike, my interpretation is a dike, an electrical current shot through the ground, made a pathway through the ground, and that draws material up to it and forms sort of a mound, and then the winds plastered against that, and they were supersonic or close to supersonic and made these wind forms.
I think you have something to it, like my idea that there is a current running along the dike, and that as material is, because there's the right-hand rule, there's going to be current running across it now, and it's going to be slamming into it. And of course, this is, pretty much liquefied and very hot, as it's carrying so much current, and things are just piling up and gluing to it, and that would be an interpretation of that. But of course, it's. Now,
if you go to the left, there's going to be another one. I'm sorry, to the right.
we flipped
we
over.
spun around a couple times.
Sorry, I
Yeah,
know,
right.
spinning around a bit. Yeah.
Go a ways to the right, and you'll find another line of
Over here.
Oh,
yeah,
there it is.
Now it's appearing. Now go down. Now zoom in on that, and that's another line of buttresses. So the wind front has moved,
You're right.
and this has been buried. It's partially buried,
Mm-hmm.
but its tops are still sticking out.
And this is some of the most gorgeous terrain. Apparently, the multicolored rocks and everything. It's just layered beautifully and, magical almost. The colors that the rocks look like. I don't think we have. The Grand Canyon is the closest thing we can compare it to because we can see all those different layers. But you can see in some of the buttresses were laid down in different layers. People go to take pictures. It's just absolutely amazing.
Yeah, I can see the storm, building and then ebbing away, and these winds shifting over time and creating new wind fronts where it's creating these different features in parallel to each other, and you find these long. This is probably 50 miles or something across the desert here that we're looking at.
Mm-hmm. Amazing. Let's go.
Yeah,
That's some really cool stuff.
It has a very spinalness to it, doesn't it? Like a very vertebrae-ness.
It does. It has an organic sort of shape to it. It rises and falls in amplitude, and it has very regular features once you start looking at it. It's not chaotic at all. You start to see regularities in how they form. And you can tell where the winds were faster and slower, and where more material deposited. So over North Africa, there's more features like this that are, these kind of turbulent patterns that are left in the mountains with craters and long linear mountains like that.
Didn't we go over part of that in Mauritania area?
Up around Morocco and up in Mauritania, where the eye of the desert or whatever they call it is, but up here up near Morocco is where you see some of the best stuff. In these I think it's the Atlas Mountains, maybe, I'm not sure, but they're up in these mountains here. Yeah, if you go there near Fez, I think just south of where it says Fez, F-E-S.
Mm-hmm.
Great hats.
Right there's, and then you get in close and you'll see these kind of forms.
Oh, okay,
there's one.
Yeah, they're all up here, yeah.
That kind of looks like
right above Tilmerit.
Yeah, those are all, you can see the windblown form, and look at that long linear.
Wow. Oh, yeah.
And then to the south, I guess west from here. I'm not sure how we're oriented.
Oh, yeah. Spin around again. There we go.
Yeah, down into the desert more. I see more.
Like this area.
Oh yeah, look at that.
There.
Uh-huh. Yep. That almost looks like Jupiter, that turbulence right in Jupiter.
Yeah.
Yeah. And then the little ovoid features are where the whirlwinds were pressing down on the land, blowing against it. And then in between, it's sucking up. And if you look at Jupiter, that's exactly what you see.
Yeah, exactly.
Multiple vortexes all over the place, strung along in winds that are alternately blowing down, and then sucking back up.
That's amazing.
So that's
Yeah,
geology.
that one would be a nice one just to do a side by side, you know. As just as far as like, as far as entreating someone to explore the idea, the very similar, you know, just as far as first impressions go.
Well, I'm giving you a preview of my next set of articles.
Right. Okay.
You guys
Thank you.
are privileged because that's what I'm doing. I'm actually doing side by side, showing views from Google Earth with views from Jupiter and comparing some of these features and explaining them.
Nice.
Don't move it. Don't move it, DJ. Don't move it. Don't move it.
Okay.
Okay. Go back in where you were by where it says
Yeah.
Titnali. Stop
Yeah.
right there. Perfect. Yep. Perfect. Stop. Wait. Too far. Because I wanted to show. Because check out this it scrolls to just out.
Off to the right.
There you go. How it's like this spiral shape. There's a twist happening there where it kind of goes up and then back down and around. You see it? Where it kind of looks like it twisted.
Near Titnali? Is that where you're?
Yep.
Over here?
Yep.
Yeah.
And then there's like this nice S curve that goes to the right up by Astad, and then it goes back down. You see it? And it creates a look of a actually a twist in the line. And there's a couple spots where it separates there too.
I do see the sort of.
I see what you're talking about.
It almost looks like if the middle of the screen is sort of like a source of fire, and that there's flames going up by Titnali up that area. You know, like it
All the way up to Asdad and out to the right a little bit further.
So, yeah, and something about it is quite reminiscent of those images we were looking at the beginning of the moon. That shape that was left in the trail of the.
Yes, I see what you're saying.
You're absolutely right.
All right. Yeah.
And we got to understand that probably the moon is. There's parts of the moon that have been completely buried in dust. I mean, there's no air. It's going to just land. It's going to basically suck it up like dust, and it's going to attract to this body and just sort of stick to it. And we saw the whole moon was covered in this fine layer of dust, compared to, say, Mars, which everyone has seen beautiful pictures of Mars. No one asks, got a question for you. Where are all these friggin' rocks from? Is someone just throwing them around? Because, the island...
That's a good...
Sorry, go ahead.
No, that's the question I have, is like, where did all the material come from? Did it come from out of the interior of the Earth and spew out, or did it come from space? It was the primordial mountain stuff falling out of space from discharging from Mars or some other planet. I don't know. I don't know where the material came from, but there's a lot of material that is electroplated like this across the surface of the Earth. I mean, all the continents, to me, they're just electroplated on top of volcanic cratons, plutons, or whatever the correct term is. It seems to me.
Well, we can definitely see that certain areas, especially when they become changed, and Edwin would probably be able to describe this more. This his idea of.
Oh, he apologized. He couldn't make it today. But
well, we'll miss him, and I'll try to do him justice. But he's referring to the transformation of certain materials, and of course, we were talking about how a star can mature. Anything can be, according to Don Scott, a star if you give it enough current. But there seems to be a situation which occurs where a lot of iron gets into there, and this concentrates magnetic fields and so forth. We can see that. But once sort of metallic components are sort of interspersed with this dust and they're sorted, they create current pathways like wires, basically. And they get hot. obviously, because they're trying to conduct current because something is trying to get at the electrons that it wants that are deeper inside the Earth through either the water or whatever is holding it, and it's looking for a point to withdraw energy. And of course, as you said, once they're laid down, they become a place to reach for, so to speak. You're saying though, Andy?
I was just going to reinforce what you're saying, because here in Tucson, I watch the weather patterns daily, and I have been for, since I got into Electric Universe for the past 3 years. And the cloud formations, summer and winter, both thunderstorm and winter skies, there's a pattern to where the clouds form, and of course the mountains are involved. But I noticed that there are two areas west of town that clouds always form over, and the same repeating kind of patterns, and they're both over copper mines. And so, and in fact, I went and visited one of the copper mines, and they actually use, they study lightning patterns and use the lightning strike patterns to give them indication of where to go look for minerals. And that's actually been written up in some technical papers within the mining industry, but it's not, I don't think, widely known outside of mining engineers that...
it will be now that you've mentioned it, because I want to tell this to everyone. Yeah. Holy crap. I mean, what is it?
This area here, you see Green Valley. It says Green Valley. That's in Sarita. Those are all copper mines there. And a large cloud formation forms generally over that area. That's on the southwest of town. And then to the northwest of town, where you see the Marana, go up by Marana. And then just to the left of Marana is another area you can see that is a mining area. That's another copper mining area there. And clouds form over that. And these two clouds, they will literally interact with each other. You can watch it happening.
Wow.
That's just, I mean, I would, at that point, I almost want to go and throw down the pen and go, okay, we're done. We obviously, it's electrical. We can stop. I mean, this is the type of thing I was referring to when I said we need to find a practical application for the electric universe, something that people can hinge on. Like weather's a good one. We were talking with Phil about that. The weather, that's a tangible benefit. This is a tangible benefit. We're studying lightning to find out where, if you could say, well, okay, but you're only looking at the tops of the current. Here's the bottom of the current, and you can start pointing out to other people where there should be more stuff that they can go mine. I mean, that would be confirmation of a theory, type of thing.
Mining engineers also use looking at breccia pipes up in northern Arizona. They use the breccia pipes. They use magnetometers to find them because they have a dipolar magnetic signature around them. And then they mine them because down in the throats of them they find uranium.
Of
course.
They look for kimberlite to find diamonds.
Kimberlite, yeah.
Can we just real quick scroll back over to Greece? I just want to show you guys something interesting that I just saw as we moved away from it.
To where?
So, from far away, Greece and Italy and just
Greece and Italy. Oh, okay.
Yeah, if you don't mind.
Yeah.
But you are making me
it's a long way.
Well, yeah, I know. It was just this weird little one more little thing to add. Okay, stop. See right where it says stop. Go down just a little bit so that it's Romania, where Romania is.
Go down? Oh,
yeah, okay, stop. Right where you are. Okay. Perfect. Okay, you gotta stop. Just right where it is. Okay, so it's where it says Romania, there is like a yin-yang pattern. You see it where it goes up by Slovenia and then through Romania and then down through Bulgaria.
Yes.
Like word S through there. Bloop, 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 bloop.
It looks like a galaxy.
Yeah, and then it kind of comes around the corner of the Black Sea and then down, and then it's kind of there's this similar thing happening down in around the word Saudi Arabia. So I don't know what all that means, but it looks like a giant that goes. It's like a connection between that space that we were just looking by Morocco, and it goes all the way up through Spain and around that the Ural Mountains, and then comes down through. And then it connects and makes this S shape, and it comes back down all the way through Saudi Arabia. It's this gigantic and then it actually goes
Let's-
up through the top of Turkey and comes up through Afghanistan. The second fractal of it kind of branches out there,
Yeah,
and it makes this whole landform this shape.
I haven't. I've noticed it before, and I haven't looked into it, to be honest with you. The wind pattern, it's a wind pattern in Saudi Arabia. I mean, the winds follow that. And you can follow the dune patterns, and they confirm the wind patterns, and it makes that swirl, and you get virtually the same swirl up above. And it could be, in my view, it could be one of two things, Heather. It could be that it is a subsurface current that takes that form, a looping current that
Like
then the weather patterns follow and create windblown mountains and stuff along that feature. Or it could be just a wind only thing, but I suspect there has to be maybe some ground current involved in making that feature.
Would the telluric currents be somehow like helping to mine this? Like when we look at, like, we'll go back to Jacob Gable, or we'll go back to Billy Elverton. Whenever they're doing the above ground plasma discharge, there's something happening within the below the surface as well. When we talk about telluric current.
Well, it's in if you think about capacitance. See, I think about the atmosphere and crust as part of a capacitor in the electrical circuit. And so if you think about capacitance, you have two capacitor plates. What happens is when you charge one side, the other side builds charge to equal and opposite to balance. And so where the charge is it building in the ground first or in the atmosphere above first? I think it's building in the ground first, and then the atmosphere responds. But that's just what I think.
Actually, as far as we know, there's no time frame in theory or in the Coulomb's law at all. So it's a simple if-then scenario. If it is there, it is there. There's no, it's electric charge is, well, fairly instant, I guess. That's what Get Wall was trying to talk about. Like, there's a force that we could, if the charge changed in Andromeda, we would know it here instantly before we saw it, millions of years later.
But capacity is like a tank, though, too. I mean, just to give you an alternate, at least maybe angle on it, the more capacity, the longer it takes.
You're absolutely right. I'm not saying, I'm saying that they do resist changes in voltage. You're absolutely right. But what I meant was
simultaneous.
If you are at a voltage here,
the opposite
you are
charge
there
happening.
Yeah.
Let's say simultaneously.
Yeah. I mean, it would take time for it to change if it had to change, but but whatever it is there, and it's just a math thing. I don't know.
Sometimes I think, is it like when you switch a note key, like you're a C and you're like vibrating within a C, but then as soon as you switch to a G, it's a complete, like it's an instant change within that.
That's when you start thinking about how they, how it oscillates, perhaps,
Well, yes, obviously there's
Andy would have much better insight into this than I would, because I've got a double E degree, but it's theoretical, not a lot of hands-on. But I've seen your hands-on stuff, so it's very impressive, of course. So.
Well, a capacitor stores energy, so the charge builds over time, and then you get what I call it is a reflection. I mean, when you think about one plate, the other plate reflects what it's doing.
Right.
Opposite polarity. But it builds over time, but the response, like Neil says, I think it's what he was saying. It begins immediately. Once it starts, it's not going to stop until those charges get equalized somehow.
Right.
Exactly. That equalization generally is going to happen with a lot of motion. If there's something in that capacitor that's fluid and ionized, then like a plasma, which is what the atmosphere is going to be, it gets ionized in these events. And so you've got a partial plasma atmosphere, and the whole atmosphere is responding electrically. to whatever's going on in the ground below.
Mm-hmm.
And there would be inductances and everything else.
What the source is versus the, is there a source?
Well, the source, now that's I think it could be different sources. Anything, the way I look at it, anything that happens external to the Earth, say it's a huge solar flare, or say it's an errant planet like Mars or Venus passing by, or it's a huge comet, or a supernova occurs and causes disruption in our solar system, causes the sun to flare or CME.
Right.
Any of those events would change the electric field of the solar system, the environment that the Earth is in. And so that would demand a response internally to the Earth. The internal electric field, the other side of the capacitor, is going to respond to what's going on out in space around it. So if the electric field amps up, then the Earth's going to amp up in response. And the ground currents are going to start flowing in response. And you start getting volcanism, and then volcanism begets a lot of ionization in the atmosphere with the dust and pyroclastic dust and everything. And things start cycling up with higher and higher charge densities in the atmosphere. And eventually it results in storms. That's what I see going on.
Mm-hmm.
And there's something to that. I mean, obviously, everyone remembers, or not everyone, but most people would understand that there are references to tornadoes of fire, in biblical type of things, and that's, like I said, biblical. To imagine a hurricane of fire that is 5 times the size of a regular hurricane, even though I've never seen one like that, but I'm sure that you could start messing around with the ground pretty bad if you started being at that level. And that could be from a localized event. But as you can see by some of these things, like from Slovakia to Romania to Bulgaria, all across the Black Sea to Georgia and Azerbaijan, and then Turkmenistan and all this other thing, that was something that, and all the way through to Tibet, that whole friggin' thing is coherent. It's together.
That's right.
That means it happened at the same time.
That's right.
You can't.
Absolutely. It's coherent. You can see it in the flow patterns. It's coherent, and it was a storm that dragged these winds to it, and
which could have been over Tibet,
And it sat over and created the Himalayas. The Himalayas, the whole mountain arc, is a windblown formation.
And interestingly,
as are the Sierras, and the other mountain arcs, the Andes.
Mm-hmm.
We can find these windblown features down in the southern Andes as well. The evidence of these up and down drafts and turbulent flow down in the southern part of the Andes, down Patagonia area,
right,
Argentina.
And they would have been rolling, like as you mentioned, those loops. But you'd have I could picture these paths of mountains being formed, and in the valleys would be just like a straight shot of a tube of fire, plasma basically, running through them. And as you had mentioned, once some of these accelerate to beyond the speed of sound, they're going to be blasting patterns into the rock faces beside them, and there's nothing you can do to stop that. That's just what's going to happen.
If you look at a really powerful mesocyclone storm, thunderstorm, the kind that happened and spit out the tornadoes over Oklahoma and Kansas in the summertime, those things will start glowing green. And I know that the atmospheric scientists say, well, that's just the water up there, and it's and it's like ocean water turns green. It's because it's reflecting that light wave. And they're saying that the cloud up there has so much water in it that the sunlight filtering through it is the green gets through, and so it glows green. But I've looked at so many pictures of mesocyclones. That green glow is there even after dark. I mean, it's a green glow. It's coming from inside the cloud. Those clouds are blocking the the sunlight all around. And if you look at a storm cloud that's heavy with water, it's gray. It's dark gray to black on the belly. It doesn't turn green until it turns into a mesocyclone and starts spinning up. And so I can imagine these big cyclones that are blowing against the ground and sucking up from the ground in big tornadoes that were glowing. I can imagine them being plasma vortices that were in glow mode. I would almost expect it based on what we see. Look at that, right? That light from within, I mean, the sunlight is shining from behind that cloud. But if you look up in the bands up above where it's shining through blue and green, that stuff is
like an aurora.
Is an aurora. Yeah, it's plasma.
A near constant, and it should be noted, like we've mentioned before, that when they first went down and landed on Venus with the landers, I'm not sure which one, it was Russians, I think. When they went and landed there, we have beautiful pictures of Venus. However, if you know, we can't see through the clouds. They're completely opaque. And the reason we can see anything on the surface of Venus is because they said, well, there was a near constant lightning. So basically they could see it was just glowing the whole time. The sky was on fire, basically.
I'll tell you something else, and this is my own experience, because it's been thunderstorm season here, so I've been going out every day and watching the thunderstorms. And when one comes over and you're underneath the leading edge of one of these things where the clouds are just in chaos, they're like going in every direction. It's like what you see. I'm trying to look for one of these pictures that shows the type of cloud formation I'm talking about, but you have to be looking up underneath the cloud, and the clouds are in this pattern of just total chaos, it seems like. And what will come from this cloud, this is when a thunderstorm is actually forming. It's not all raining yet, it's not spitting lightning, but the cloud is what I call growling. You'll hear it popping and snapping inside the cloud, but you'll see no lightning because these are small little charges, little discharges going off inner cloud, and you can just hear them, and they'll be like a constant rumble, grumble, pop, and snap, and yet you won't see any lightning going off because it's all just little sparks going off up in the cloud in this plasma formation that's growing.
This is just amazing. And I never thought about that blue glow, but I'm now saying that the first EU movie that I've ever saw was Twister. If you ever got a chance to ever watch that movie, I don't know if you ever would, but I remember when their big reveal, their big special effect at the end was they got run over by a tornado, obviously. And they had to tie themselves to a pole that was metal, part of a sink or something out in a field or whatever. And he got a chance to look up through the bottom. Now, no one's really done this, except for perhaps Jacob, what was that gentleman, Garrett Hill, I guess his name was, that said he went chasing tornadoes. We were at EU 2017 there, Andy. I couldn't believe he did that. It was like, what are you doing? You're going to get killed. But he's looking up through the thing, and you could see the I don't know where they got the idea, whether or not they got a witness who actually survived one of these things, but they showed a bluish green sort of semi bolt of lightning that was semi stable going up the middle of the tornado. And I remember seeing that, and I was like, whoa, that's cool. Now, that was 1990 something, and I had no idea what the EU was. But now here we are back. We're talking about glowing mesocyclones and tornadoes, and kudos to them is what I'm saying. Bill Paxton, you will be missed, I guess. Because, I mean, obviously, they kind of nailed it, because no one's ever done that before. That was sort of like a surprise. They thought they were being, just as close as they could to science or whatever, and they're taking witness accounts or something, trying to make it real. But still, you can see, and here's a perfect example of what we were talking about. It's coherent. It's affecting a lot bigger than just,
Yeah, look at that thing. It's the whole thing's rotating. The whole mesocyclone's rotating, and that has a huge updraft of wind in it. So this is sucking air up from the ground. So yes. in the context of Jupiter, these zones are forming in long linear storms rather than forming in a circular pattern like this. They're forming long linear jet streams that are sucking up and then pulling up those mountains, long linear mountains underneath them. Whereas the cyclones, the hurricanes, the eye of them blow downward, and they're blowing down and forming the craters. And they're all mixed up and down winds circulating in those turbulent zones.
It's amazing the connections between the two. I almost wish Phil was here. He'd be
right,
like,
well, I was saying,
right?
On Google Earth,
let's call him up.
Right? Well, when we were on Google Earth, you could see the line of storms in the Atlantic right now. So you could see the nice arc or the path kind of where they were trailing across. And like he's saying, it's like the downwards. So there have to be, so they have to get the air from somewhere. Where are they pulling it up from to push it down for in a hurricane or a cyclone?
Well, we do know.
And so I think these loops are a part of the necessary part of the capacitive circuit, because the Earth being a sphere, it's a spherical capacitor. So that geometry of the sphere comes into play. Because if you think about two equal, a normal man-made capacitor has two equal flat plates, and the charge builds in two equal areas, so you can get equal charge buildup across them. In a spherical capacitor, you can never do that, because the inner sphere is smaller than the outer sphere, and the plates will never match, and there's always going to be adjustment between them in a spherical capacitor. And I think the result is ring currents that are what we see, like coronal loops on the sun that flow through the crust and atmosphere, and that's what motivates the winds up and down and creates the storm patterns that we have.
I was just thinking if there was a relation then to the Rocky Mountains, the Tornado Alley, and the New Madrid fault then, with all these like supercells forming off in the Midwest.
Well, I think there is. I'm not. I think there is. We'll figure it out.
Yeah, let's do that.
By the way, if you guys are...
Let's do that.
Yeah.
Yeah.